talking today about conic sections first, and then some of our exponential equations and exponential graphs. But conic sections come from taking a cone and cutting sections from that cone in different ways. There are 4 different types. Today, we are only going to focus on circles as far as equations and graphs are concerned. But let's just briefly talk about what the 4 conic sections are. So if I take a circular saw and I slide my cone exactly straight through like this and cut off a little section like this, what's the shape of the perimeter that I've cut off? A circle. That's the kind we're talking about today. And you see pictures here. You also notice in these pictures, technically, a cone is a solid of revolution when you take a line like this and you rotate it in 3D around the axis of symmetry that goes straight up and down through the middle. You get a top section of a cone and a bottom section. My model here in my hands is only half of that. I could also take my slide or my saw and tilt it just a little bit so that it still just goes through either the top or the bottom half of the cone, but it doesn't go perpendicular to that axis of symmetry. It's on a slant. And so when I do that, you can kind of see this piece I'm pulling off here, how it's cut at a slant. And do I still have a circle? No, it's kind of squashed. So this one is an ellipse. And that's what we get when it's tilted just a little bit. I could tilt it so that it doesn't go across and get an ellipse, but at just enough of an angle that it never comes all the way over here to this far side of it. And so you can kind of see in the picture there what we get. And I can also pull, I think it's this one off, if I can get hold of it. And let's suppose I was cutting that off the top half. What does the perimeter of that look like to you? And remember, this cone goes forever and ever, straight on up the way I'm holding it. So that one's going to be the parabola. And the final one is if we tilt it so that it goes through the top and the bottom halves. You can kind of see in this picture how we're cutting it, and it goes through the top and the bottom halves. So I get a piece like this from one section of the cone and a matching piece from the one up above. So see how we're getting 2 of those curves or our hyperbola. So you don't really need to worry too much about exactly how we cut those. I just wanted you to understand that the 4 conic sections are from cutting a cone into sections when we turn our saw at different angles to slice through it. We will talk about the equations and graphs of all 4 types in this course, but today we're only going to worry about circles. So to get our equation for a circle, you guys know that a circle is all of the points, the ones that go around in the circle, that are the same distance away from the center, or the radius distance away from the center, right? So I'm going to use my locus definition, and I'm going to say that the distance from some point, xy, on the circle to the center equals the radius. That's what a circle is. If I draw a picture of that, I have a center, and I'm going to label that center HK. So it'll be easier to plug into the formula. I'm going to need some variables I can plug in there. Now, XY might be here, but this equation is going to have to be true whether I'm talking about this point or this point or this point. The ones that I draw in the circle are all of the ones that are going to be that same distance from the center. And that distance needs to be R. So my distance formula says the square root of, and if I want the distance between xy and hk, I have to do x minus h and square it, plus y minus k, and square that, and that needs to be equal to my radius. Now for my standard form of the equation, I don't want to have that square root sign in there. So I'm going to go ahead and square both sides, which gives me this equation, that x minus h squared plus y minus k squared, no square root sign anymore, equals, and the other side, since I've squared both sides, needs to become an r squared. Notice that the center is the opposite of what you see in the parentheses. If the center is 2, 3, that's going to be x minus 2. So you see a minus 2, but the center is at 2, comma. Kind of like when we were completing the square on parabolas last year, y equals x minus h squared. We had to take the opposite of what was on the inside there for that first coordinate. Now we could also FOIL all of that out, right? And we'd have an x squared and a y squared and some other terms going on in there. If we FOIL it all out, we can get the general form for the equation. And for the circle, it's going to have an x squared and a y squared. It's going to have something x and something y and some kind of a constant. But in general, for any of these conic sections, you could have an x squared, you could have a y squared, you could have an xy term, you could have an x term, a y term, a constant term, but we want it equal to 0 for our general form. The order matters. You're going to, if you have an x squared term, you're going to write it first. If you have a y squared term, you're going to write it next. Now, you know, a parabola would be a y equals, and you'd have an x squared, but not a y squared. So if it were a parabola, this would have been a 0 y squared thrown in there. You also may remember some of those that you did last year had an xy term in them. We did things like xy equals 8, and we rewrote that as y is 8 over x, and we did our t-table and got some points that we plotted for these two branches of a hyperbola, one that's kind of turned on an angle in there. So let's try this out and see if we can do standard form and general form. And I'll also, for that matter, talk about drawing the graph of a circle, even though this problem doesn't specifically say that. Standard form is the first one. We just plug the center in. So we're going to do x minus the negative 2, so it becomes a plus 2. So we see the opposite of what that coordinate is for the center. Plus y minus the 8 squared equals, the radius is 5, and I don't care which. You can write 5 squared, you can write 25, you can write both, and I will still accept that for the general, for the standard form, but I've got to have the parentheses squares when it says standard form. Questions on that part? Okay, let's get the general form next. To do that, we're going to FOIL this out. So we're going to have x squared plus 4x plus 4 plus y squared minus 16y plus 64. I know I want equals 0 on this one, so I'm going to go ahead and do minus 25 equals 0. Order matters. I'm supposed to start with the x squared term. I only have this one. Next, I'm supposed to do the y squared term. If you look at the formula you wrote down, I only have this one, so x squared plus y squared. Then I'm supposed to do xy. Do I have any terms with an x times a y? So I can skip that one. It was 0 xy on this one. I don't have to put the placeholder in there. Then I need my x that's not squared. So I have a plus 4x. Then I need my y that's not squared. So I have a minus 16y. And then I need to put my numbers together. And let's see, 4 plus 64, that's going to give me 68 minus 25, what, plus 43? Is that what you guys are getting? And that one is our general form. So that much is pretty easy, right? You will have ones that say to graph. And so here's what I expect on a graph. Put a dot where your center point is. Sometimes you may have to change the scale. I don't have to on this one because I moved the grid enough that we could get it all in there. I'm going to, since my radius is 5, I'm going to go 4 boxes straight up. Or I'm sorry, my radius is 5, so I'm going to go 5 boxes straight up. There's 1 box, 2, 3, 4, 5, and do a dot there. Straight down, 1, 2, 3, 4, 5, and across 2, 3, 4, 5, and to the left 1, 2, 3, 4, 5. I want to know the coordinates of those 5 points. I want them written on your paper, either in the blank white part of the box or on the grid, wherever it can be read. The -2, 8. In this case, it was given to you in the problem, so if you don't label it right there, you still need to write down in the white part that the center is -2, 8. Now, notice these points where I went straight up and straight down. The x coordinate is still -2. That's still how far I go left or right, isn't it? If I started at 8 and went up 5, 8 plus 5 is 13. If I started at 8 and went down 5, 8 minus 5 is 3. These other 2 points still have a y coordinate that's 8, because that's how high we go. So if I started at -2 and go 5 more to the left, that's -7. If I started at -2 and go 5 to the right, -2 plus 5 is +3. And do the best you can to actually draw a circle that goes through those 5 points. And that's what you'll do when you're graphing circles. Any questions on that? Then let's shift gears, and we're going to talk about exponential graphs. So exponential growth, y equals 2 to the x, y equals 5 to the x, y equals 7 to the x. Exponential decay, y equals 1/2 to the x, y equals 1/3 to the x. But now we're going to have transformations on those, and I want us to do them with transformations, not just trying to make wild guesses for a t-chart. So reviewing these, you've already got this in your notes. If you have, wherever you've got an x, so in this case, our x is in the exponent, and if on the inside you subtract, that means you've moved your original graph to the right. If you add, you've moved it to the left. If you have y equals, I don't know, 2 to the x, and then not where the x is, you have a +3, so on the outside, that means you went up 3. If this were a minus, you'd be subtracting. The reflections, I'm going to show you another way with these exponential graphs that we don't really have to think about it as a reflection, make it easier. But if we have ones in general where we're reflecting across the x-axis, instead of y equals, we write it minus y equals, and then we multiply both sides by a -1, so we have a y equals. To reflect across the y-axis, wherever there's an x, we change it to a -x and figure out that graph. So we are now going to start trying to graph things that look like this. And oh my, if I just started trying to randomly guess, well, I don't know what x's I need. I don't know if I need x equals 0. I don't know if I need positive ones, negative ones, fraction ones. I don't know what the heck to start picking. And that's a lot of trouble to figure it out that way. The easier way is use algebra, manipulate things around so your exponent starts with a +1x. This one doesn't start with the x, and when we do get to an x, it's not a +1, it's a -1. So I'm going to think about that as y equals 2 to the -x minus 2. Since I want to start with a +1, I am going to factor the -1 out of that. Just in the exponent. So if I factor a -1, Maggie, what is that going to leave me for this exponent? Everybody good with that? Now I want you to think about your exponent properties. You know that if you have 3 to the AB, that's the same as 3 to the A to the B. Usually we think about it as starting with the way on the right and going to the left, but you know those are equal to each other, right? I've got that kind of a pattern up here. I've got them already multiplied together like this. So now I'm just going to regroup. I'm going to say, oh, I could take the 2 to the -1 to that x plus 2, and that's the same thing. So if I do that, what's 2 to the -1? A half. Do you know how to graph a half to different exponents? Have we done exponential graphs, a half to the x? So we're really graphing a half to the x plus 2. We know how to graph y equals a half to the x. If I have a +2 on the inside right here where the x is, which way do I shift that? Now, up 2 would be a +2 out here. If it's on the inside, where do we shift, Mario? So we're going to figure that graph out, and then we're going to go left 2. So we are going to do dots for the helper graph and actually draw the solid graph for the final. So I'm going to do dots for y equals a half to the x. Is that growth or decay? It's decay. So I know it goes here. I just want to graph all of my lattice points, integer coordinates. Since it's decay, everything off here to the right-hand side is going to have a fraction for the y coordinate. And if I go to the left, a half to the -1 is 2. If x is -2, a half to the -2 is +4. If x is -3, a half to the -3 is +9. So those are my lattice points for this exponential decay helper graph. I know I need to shift each of those 2, so I take each of those lattice points. This one comes to the, what's to the left 2. It was at -3,9. 2 more to the left is -5,9. This one was at -2,4. 2 more to the left is -4,4. I had one at -1,2. If I move that to the left 2, it is -3,2. My old y-intercept goes to the left 2, so it is now -2, 0. I should get my new y-intercept, so I can go to any one of these equations. If x is 0, what's my new y? So pick whichever one you like. I kind of like either 2 to the -2 up here, or a half squared is how much? A fourth. So my new y-intercept is 0, a fourth. I did have the positive x-axis as a horizontal asymptote. If I shift that x-axis to the left 2, does it look any different? So I still have the same asymptote. So my final graph comes along like this and still has that same intercept, that same asymptote. I'm going to do a couple more of these because I know this is kind of a new concept. This one is very similar. See how much of this you can do on your own. We want to start with plus 1x, and this one starts with minus 1x. Elena, what's in the parentheses? Thumbs up, thumbs down. How many of you wrote that? Next step, how am I going to regroup here? Who can help me with that? Lindsay? So I'm going to group the 1/3 to the minus 1, which becomes 3. So I have y equals 3 to the x minus 1. Do we know how to graph y equals 3 to the x? Which way will this minus 1, which is now on the inside, make it go? Can everybody point? Which way will that make it go? It's going to make it go to the right one. So do your dots for your helper graph, y equals 3 to the x, just for the integer points. And you've probably done enough of these. You can kind of do like I modeled on the last one. I don't think you really need a t-chart for that. So it's going to go through 0, 1. Charlene, can you tell me another point that's on y equals 3 to the x? 0, 1. I'm trying to graph y equals 3 to the x. What's another point on this graph? So we do a dot there. Any other lattice points on this grid, Sarah? And those are our only lattice points, right? So now we're going to shift each of those to the right one. So who can tell me these coordinates? Tyler? I'm going to take 1, 3 and shift it to the right one. What are these coordinates going to be, Jack? 1, 3 was this green one. If I move it to the right one, what are the coordinates of the blue one? I'm at 1, so 2, 3. Okay. And this one, I was at 2, 9. Charlotte, if I shift 2, 9 to the right one, what do I have? Find the new y-intercept for me. If x is 0, plug into one of those equations. That's my actual graph. Dylan, what will that give me? If x is 0, what will I have for y? So my new y-intercept is 0, 1/3. I did have my green one went off here in the negative direction with the x-axis as an asymptote. If I shift that to the right one, does it look any different? So I still come down to that same asymptote. So here is what my graph would look like. And you give me the labels either on the graph or in the white part of your problem set paper, the coordinates for those points, wherever it makes most sense and can be read. Because when we shifted this around, so it was 1x for the parentheses, in the place where we had x, it's now an x minus 1. And if on the inside you have a minus, you go that far to the right. One last example, and then we're done. Does this one start, and this one's actually easier, does this one start with 1x for the exponent? So what are you going to factor out? 2. Well, it's kind of already factored out, right? So if you just do your regrouping, what is this the same as graphing? So we have an exponent with a 1x in it. Okay, what does this equal if I regroup like this? Do you guys know how to graph y equals 4 to the x? Okay, do that real fast, label your points. And then 4 to the x does not have anything that now needs to be shifted. We've used our algebra to get it to one that doesn't even have to have a shift. So Shayla, tell me a lattice point on y equals 4 to the x. So 0, 1. Austin, tell me another lattice point. What would the next lattice point be? On the graph or not? What would be the next one, Kyler? 216, that's off my grid. It tells me I can't cross this vertical line for y equals 2. Got my asymptote here. I'm going to miss here, but you get the idea. Questions on what we've covered today? Then it is homework time.